Tashi Delek, and welcome to this session. Today we are going to cover up second topic of this chapter, that is properties of a triangle. Okay, and in this topic we will be learning how to prove two theorems, and we are going to do a few related exercise based on this topic itself. And let's move towards the main topic. Okay, this is the today's topic. Properties of a triangle. Actually, we have done the first property of a triangle in last sessions. That is, do you remember? If you add up three angles in a triangle, it is always 180 degrees. Do you get it? And we have already proved this also. This theorem and sum angle property theorems is already done. And now today we will be proving two more theorems of triangles. And that is, you have already done this in class 8, you have already learned it, you use it in exercise, but you don't know how to prove this one. And you have to know why we are getting this kind of properties. Okay, so we are going to prove two theorem today, and so that you just come to know why we are using this reason. Okay, so do you remember this one? First theorem that says that, prove that angles opposite to equal sides of an isosceles triangle are always equal. That means what? Okay, in a triangle, yes, in a triangle, if I draw a triangle, let me write the vertex here, A, B and C. Okay, angle opposite to equal side of an isosceles triangle. So you have to know isosceles triangle, clear? Isosceles triangle means what? In a triangle, if two sides are equal, then we can just call it isosceles triangle, understood? So let me take here isosceles triangle. So we are going to prove this one. The triangle is an isosceles triangle, so that means AB is equals to AC. Let me take this two is equals to each other. Got it? So in this triangle, if two sides are equal, that you have done in class 8, okay? If two sides are equal, then opposite angles are always equal. Which one is opposite angles? And the side BC, the opposite angles of side BC is C. And same here, the opposite angles of side AC is B, angle B. So if, you can just, okay, you have already done this one. If two sides are equal, then opposite angles are always equal to each other. Correct? Which two opposite angles? B and C. If AB and AC are equal to each other, that means what? Angle B is exactly equal to C. So you have done and you have used this in your reason also. Okay? So now today we are going to prove how these two are equal to each other. We are going to prove why we are getting these properties. Okay? Let me prove these theorems. One by one. So as you know that whenever you are going to prove theorems, you have to know what you have to write it. Okay, first step by step you have to write it. So first of all, what you have to write it down here, given. Okay, now this is not there. Okay, I'll just write it down here. Okay, so first of all, you have to write it down, given. And you have to read the questions and write the givens. Okay, and the diagram is on it. You have to draw an isosceles triangle. Draw the diagram first. And the second step is given. What else is given? So what else is given? This is given. So isosceles triangle is given. So triangle, we know that triangle ABC is an isosceles triangle. Okay? Isosceles triangle. That you have known it. Okay? If this triangle is an isosceles triangle, means which two sides are equal to each other. So that is given here AB. So we have taken AB is exactly equals to AC. That is given. And after given, what you need to write it? You need to write it to prove. Okay, what is your question? What you are going to prove? Okay, so write it down to prove. What you are going to prove here? See here. So if two sides are equal, which two angles are equal? B and C. Why these two are equal to each other? So you have to prove this one. So see, you have to prove that whenever in a triangle, in isosceles triangle or in a triangle, if two sides are equal, then opposite angles are always equal. So we are going to check how these two angles are equal to each other. Okay, we are going to give the reasons and then come to get the answer. Okay, so angle B is equal to angle C. We are going to, if two sides are equal, why these two angles are equal to each other? We are going to give the answer for this. Understood? Okay, next we are going to write the constructions. Okay, what we need to construct? What we need to construct here, and as we have known it in the last sessions, we have done it congruent triangles. Okay, if two triangles are there, if three parts of the two triangles are equal, means two triangles are congruent to each other. So by using congruent rule, you can prove this theorem easily. Okay, so what you need to do, construct in this figure, you have to bisect this angle and make two triangles, okay? So bisect this angle A, bisect means these two are equal to each other, and then bisect a line. This line is joining BC at D. Got it? So this is your construction, and now you have to write it here, okay? Bisect. Okay, easily I'm writing in this way. Bisect angle A and join. You can write join AD. This is your constructions. After constructions, then you have to move towards the main solutions and the proof. So you have to prove. How do we prove? As I told before that, you have to use congruence rule. Understood? So now we are getting two triangles. Can you get two triangles? First triangle and second triangle. And we are going to check, we are going to prove that two triangles are congruent to each other. Okay? By using three parts. Which rules we are going to use here? So how do we prove this one? Okay? Now take down in triangle. In triangle, first one. Which two triangles? Okay, you can write it any order. If you are writing from here, or you have to start from here itself. So we are going to start from B. Okay, in triangle, yes, see A, B, D, and triangle ACD. ACD. Okay, in these two triangles, which three parts are equal to each other? First of all, look at here. What else is given? So what else is given here? This side is already given. So in given, side AB is equals to AC. This is given. Write it down. AB is equals to AC. That is given. Got it? And the next one, this angle, the included angle is also given. Not given, it by construction you have got this one. Okay? So what is this angle? The name of this angle is BAD. So angle BAD is exactly equals to CAD. Angle CAD by construction. So by constructions, you have to you got these two angles are equal to each other. Understood? And now come to here, first part, second part are equal to each other. And what will be the third part? Okay. So now see here, is there any other parts which are equal to each other? See, AD belongs to this triangle. AD also belongs to other triangles. So AD is common to both the triangles. So let's write it down here in this way. AD is exactly equal to AD. You can write it common. So now, did you get it? Three parts. And out of the six parts, three parts are exactly equal to each other. So which rule you use here? Side and side included angles are equal. That means you have used side angle side rules. Okay. So therefore, by looking at these three parts are equal to each other. That means two triangles are congruent to each other. So triangle ABDS congruent to triangle ACD by which rule you use? By side angle side rules. You get it? And after proving this one, still your answer is not getting. Okay. Now see what you need to do. You have to get this answer. Okay. Angle B has to be equal to angle C. So now check. Okay. Now we proved that two triangles are congruent. And do you remember CPCD? Okay. If two triangles are congruent, then all the other parts of all the corresponding part of two congruent triangles are always equal to each other. Got it? So angle B is when I just fold this up and B is exactly coming on the top of C. So that means B is corresponding vertex of C. So that means angle B is exactly equal to angle C because these two are the corresponding part. Understood? So thus you can write it down. Thus angle B is exactly equal to angle C by CPCD. You use CPCD, okay? So hence you prove because you have got this answer. So that means yes, if two sides of a triangle, of an isosceles triangle, isosceles means what? In a triangle, if two sides are equal, then opposite angles are always equal. Why? Because of this, okay? You have proof and this theorem by using congruence rule. Do you get it? Okay, now see here, this next one is totally opposite to this one. Got it? And in this, here it's written that if two sides are equal, then opposite angles are equal. And in the case of this, in a triangle, yes, in a triangle, let's see, write it down, A, B, C. If two angles are equal, see here, if two angles, let me draw in this way. See, this shows that these two are equal to each other. Got it? If two angles are equal, then opposite sides are always equal to each other. Got it? So which one is opposite side? This one is the opposite side of angle B, and this one is the opposite side of angle C. So angle B is, if angle B is equal to angle C means what? Side AC is exactly equal to side AB. You get it? And you use this in class 8 again. and now we are going to prove. How do we get this one? Why these two are equal? If two angles are equal, opposite sides are equals. Why these two are equals? Okay, so now let me write one by one. So the diagram is done, and now we are going to do here one by one. So first of all, write it given. So what is your given? Here again, yes, in a triangle. So in triangle, what is the name of this triangle? ABC. And which two? Okay, what are given there? What are given here in this triangle? Angle B. Okay, angle B is equals to angle C. This is given. In a triangle ABC, angle B is equals to angle C. This is given. And now to prove, what is your question? What do you have to prove here? To prove AB, okay, if two angles are equal, what is the opposite side angles of B? AC, yes. AC is also equals to AB. So you are going to prove this too. Okay, AC is equals to AB. Okay. Now same construction you have to draw. So constructions. What you need to construct here? Okay, again same. We are going to bisect. Bisect angle A and join. Okay, yes. Align these two BC at D. So yes, bisect means what? You have to draw like this here, and this angle is exact equals to this angle. So this shows that, this symbol shows that these two are equals, and here I just mark it 2 means these two are equals. Understood? And now write it down here, construction. Again bisect. You can write it down, bisect angle A, and I'll just make it an easy way. So join AD. You can write it this way, join AD. Or you don't need to write it lengthy. Okay, just write it in a shortcut way like this. Bisect angle A and join AD. And now we are moving towards proof. Main solutions. How do we solve this one? And how do we prove this theorem? And we can prove this theorem again by using congruent rule. Got it? So what rules you are going to use? Let's check. Okay, so one by one. So here can we find two triangles? First triangle and second triangle. You have got two triangles. And in these two triangles, which three parts are equal to each other? You have to check again, okay? So first of all, do write it down. Which two triangles you are going to check whether two triangles are congruent or not? Which two triangles? In triangle ABD. Again, take ABD and triangle ACD. Got it? Please do take this in order, proper. If you are writing this in order, proper from the beginning itself, then your statement will be always correct and you won't get any difficulty in the in writing statement. Okay, so ABD and ACD, and now in this two triangle, which three parts are equal to each other? First of all, this is given. Angle B is equals to angle C, that is given. And second one, again this one is by construction you have written. So what is that angle name? BAD is equal to angle CAD, because this main angle has to be inside. It means at the centers. Okay. So angle A, BAD and CAD by constructions. Two constructions you have to you got it. Two constructions. And what is the last one? Any other side? Any other parts are given or not? So see here again, yes, AD belongs to this triangle and AD also belongs to the second triangle. So that means AD is common to both the triangles. Okay. So write it down again. AD is equal to AD. So here common. You can write it down common. Do you get it? And therefore, yes, therefore triangle ABD is congruent to triangle ACD by which rule you use? Angle, side. Fourth rule you use. So by angle, side rules. Okay, after using these rules, once you prove that two triangles are congruent to each other, then what about the corresponding parts? All your corresponding parts are always equal to each other. Correct? So now let's check your to prove or a question. Okay, what is your question? AC and AB. Is AC is corresponding to AB? Let's check here. AC is corresponding to AB. Again check here. When I overlap these two, when I folded this triangles, can we get AC on the top of AB? Yes, exactly. AC is coming on the top of AB, or these two are corresponding sides. Okay, so therefore AC is exactly equals to AB by CBCD. The reason you can give in this way, by CBCD, you got this answer. So here AC is exact equals to AB because these two are the corresponding part of congruent triangles. Do you get it clear? So with this you prove in this way, and as we know that once you prove it, and you can use this in every exercise. So wherever you are getting this kind of exercise, you can use it proper. Earlier in class 8 you are using directly, now you have known it how to prove it also. Okay, sometimes you may get a question to prove that this theorem, and in that case you can prove in this way. You have already learned the rules of congruent triangle, so it is easy to prove. Do you get it clear? Okay, let me solve two exercises based on this theorem. So let me do. So look at the first question and first exercise. ABC is a triangle. Okay, ABC is a triangle in which altitude BE and CE to side AC. So altitude means what? And this is called as height, or no, altitude means height. Height of a triangle. BE is the height of a triangle means what? BE is perpendicular to AC. So this is perpendicular to AC, and CF is altitude means perpendicular to AB. So here it is exactly perpendicular, means forming 90 degree over here. Got it? So here you can get this one. This is given. And what else is given? Altitude BE and CE of side AC and AB are equal. So this altitude, see here, BE, this altitude and this AF, these two altitudes are equal to each other. Two heights are equal to each other. That is given. Understood? So now first of all, when you write it down solutions, do write it given. What else is given? Write one by one, so you know how to present this in your exams. Okay, first of all, in question what else is given? In triangle, write it down. In triangle ABC and BE, so it's written here, BE is equals to CF. This is given, CF. Understood? And here this is perpendicular to this, CF is perpendicular to AB, means these two are also 90 degrees. So you can just write it down. Angle angle AEB is equals to angle AFC, which is exact equals to 90 degree. Why? Because an altitude or a height is always perpendicular to their base. Do you get it? And the next one, to prove. And what you are going to prove here, and what you need to prove here in this part. So show that means prove that. What you are going to prove? These two you have to prove. So write it down. Triangle ABE is congruent to triangle ACF. Is it F? Okay, these two are congruent to each other. You have to show this. And the second one, what you need to show? AB. Where is AB? AB is equals to AC. AB is equals to AC. You need to show this one. Okay, and there is no construction. You don't need to draw any constructions, any extra diagrams, and start proving fast. So what do you need to prove? Now solution. Okay, now check where is that triangles. Okay, triangle ABE. You need to prove that two triangles are congruent to each other. So which two triangles? ABE. Where is ABE? ABE. So let me highlight this triangle so that you can get it clear. ABE. This is one triangle. You are going to prove that this triangle, and other triangle. So can you see this triangle and other triangle? I'll just overlap this one. This triangle, the pink triangle. You have to prove that this pink triangles and this yellow triangles. You need to prove that these two triangles are congruent to each other. Correct? So in these two triangles, what else is given? First, and you have known it here, this one. Okay, BE is given. BE is the one of the side of triangle ABE. First triangle. This is first triangle. And the second one, CEF, is another part. Okay, CF is the one of the part of other triangles. One part is already done, and the second one, this is already given there. Here, yes, E is given, means what? BEA is 90 degree and CFA is also 90 degrees. Second part is already got it. And now which one is the third part? Is there any third part given? And see here, so both angle A is common to both the triangles. See here, I can just call here BAF. It includes A here, and same here, CAF. So A is common to both. A belongs to both the triangles, so A is common. Okay, so we found three parts. If you got a three parts are equal to each other, then we can just say that two triangles are congruent to each other. Got it? So let me write, and how do we present? First of all, see here. In triangle, write it down. In triangle ABE and triangle ACF. So which parts are equal? First of all, what else is given? You have to write that one first. BE is equal to CF, that is given in question. Okay. And second one, this perpendicular. Your height is always perpendicular to your base means what? Two perpendicular lines are always equal to each other. So see here, angle BEA or AEB. AEB is exact equals to AFC. AFC, you have to write it down 90 degree each. Do write it 90 degree each. And the next one you can just write it as I said it here. Angle A is common to both the triangles. So angle A is equals to angle A, that is common. You can write it down common. You get it? So now see, we have just looked at here. Three parts are equal to each other means what? Two triangles are congruent to each other. Okay, so write it down. Therefore, triangle ABE is congruent to triangle ACF by which rule? So see here, you use two part means two angles and one side are equal means what? By which rule? Angle side rule. You use this rule. Correct? This one you did it in last session. Okay, you have done this one, and still we are not okay. Now first one is totally proof, and now how do we prove the second one? So now see, where is that second? A, B and AC. Look at A, B and AC. AB, where is AB? AB, see here, AB is in triangle, the yellow triangles. AB is in yellow triangles and AC is in pink triangles. Got it? So now see, these two parts are included in both the triangles. So if two triangles are congruent to each other, that means what? These two are the corresponding side of two congruent triangles. So as we know that if two triangles are congruent, all the corresponding parts are always equal to each other. Got it? So we can write it down thus, or therefore, thus AB is exactly equals to AC by, again what you use? CP, CT, symbol like this. You can prove in this way. Your question will be getting in exams like this, and you can prove in that way. Your answer, you can write it in very easy way like this. Understood? Second question, what is written there? ABC and DBC. ABC and DBC are two isosceles triangles. Isosceles triangle means what? In a triangle, if two sides are equal, that means an isosceles triangle. So here, I've just marked the angles. So 1 and 1 means what? These two sides are equal, and on the other side, these two sides are equal to each other in two triangles. Okay. So now, say on the same base in figures, show that you have to show that ABD. Where is ABD? ABD. You have to show this one. ABD means this big angle equals to ACD. So you have to show that this yellow mark, this angle is equal to this one. So how do we show this? By using those properties and those rules, and whatever you use, you can use it in here. Okay. So now let me write it one by one. Again, solution. See here. First of all, what you need to write it? Given. So in this question, what else is given? Two triangles. Okay. And then in two triangles, in triangle ABC and triangle DBC. In this two triangles, which two sides are equal to each other? So first one, AB is equal to AC. That is done. And second one, BD is also equal to DC. Okay, these two, because two triangles triangle is an isosceles triangle means what? Two sides are equal to each other. Okay, and then to prove, what do you need to prove? So here, what is your question? Your question is this: you have to prove that angle ABD is equal to angle ACD. So you need to prove that two triangles are congruent. Okay, are equal. Angles are equal to each other. This angle and this angles are equal to each other. Do you get it? And now come to here. There is no construction. You don't need to draw any construction. Start proving. Okay. How do we prove? So here, when you prove this one, do you remember isosceles triangle properties? We have just done before some time. And if sides are equal, opposite angles are always equal. Do you get it? So here in a triangle, in this triangle, can you see this triangle, yellow triangle? When I draw this yellow triangle, in this triangle, if two sides are equal, then what about the angles? Opposite angles. This opposite to this angle and opposite to this is this angles are always equal to each other. Can I write in this way? As we have already done a few minutes before, and these two are equal. Same here in this triangle. Again, this is an isosceles triangle. In this triangle, if these two sides are equal, means what? Opposite to this is this angle and opposite to this angle is this angle. So I'll just mark it cross, and these two are also equal to each other. Do you get it? And if it is an isosceles triangle, means what? If two sides are equal in a triangle, opposite angles are always equal. So opposite angles are always equal. So if this and this are equal, this and this are equal, then what about the whole thing? Whole thing will always get equal to each other. Got it? This is just by looking at your figure, you can get in this way, but you have to present in the paper. How do we present this in a page? So write it down, okay? So same here, what you need to do? Same again. You can just write first of all write it down. Now we are going to write it, how do we present? In triangle, first the yellow one, ABC. In triangle ABC, what else is given? So here the given is AB. AB is equals to AC. Since AB and AC are equal means what? Opposite angle. Which two are the opposite angles of side AB and AC? Angle B is not, okay, you cannot call angle B because angle B means whole distance. What is the name of this angle? You can just call it angle ABC. So write it down here. Therefore, angle ABC is equal to angle ACB. ACB. Okay, these two are equal. So what reason you are going to give it here? Angle opposite. Angle opposite to equal sides. Angle opposite to equal sides are always equal. Write it first. And now we are moving towards the next other triangle, that is pink triangle. So in triangle DBC, DBC, I'll just write DBC. Since in this triangle, which two sides are equal? BD, yes, BD is equals to CD. If two sides are equal, then opposite angle. BD, the opposite angle of BD is angle this one, and the opposite angle of CD is this one, okay? So write it down, yes, angle, the name of this angle is what? BD, okay, you can write it down here, DBC, angle DBC is also equals to angle DCB. Angle DCB, again same listen. Angle opposite to equal sides are always equal sides. Angle opposite to equal sides are always equal. Okay. Now look at first and second. See here. From 1 and 2, just here, what you need to do? So this angle ABD here, how do we get this? You have to get this one, ABD. How do we get ABD? ABD means this small yellow one angle and this close angle, these two angles. When you add this up, then you are getting this big angle. So what you need to do, you have to add. So write it down, adding. Okay, you can write it adding 1 and 2 we get. Adding 1 and 2 we get. So how do we add it? Add left hand side and right hand side. So we are going to add it up. So write it down, ABC plus angle DBC is equals to this one. This and this has to add it up. Angle ACB plus angle DCB. Got it? So when you add these two up, ABC and DBC, what you are getting? If you add this up, this yellow one, ABC and DBC. When you add this and this, what you are getting? You are getting ABD. So write it down, you are getting ABD, which is exactly equals to, when you add these two up, ACB and DCB, what you are getting? You are getting ACD. You are getting ACD. Do you get it? So hence we prove. So you have got this one clear. So hence we prove that angle ABD is exactly equals to ACD. Do you get it clear? First you can just look at the figure and prove it in your mind and then present it proper like this. Do you get it? So here hence we prove that angle ABD is exactly equals to ACD. All the questions are similar to this, like this. You can prove it easily by using those properties and then rules. Okay, now this is the last topic of this chapter. So that is inequalities in a triangle. Some properties of inequalities in a triangle. Okay, if your triangle is in scalene or it's not equal to each other. If it is an isosceles triangle, then we can already prove two triangles, two theorems. And now if your triangle is not equal to each other, if your side of a triangle is not equal, then what kind of properties you are going to have in a triangle? Okay, let's see here the first one. First one. Okay, let me take the first one, and through diagram I'll just explain you. So see here, the first property here is given. Okay, angles opposite to the longer side is always greater. So when you draw triangles, okay, see here, let me draw triangle in this way. See here. So this is a triangle, and let me write it here: A, B, and C. So I'm going to give it an angle opposite to the longer side. Let me write measure also 8 centimeters, and here 4 centimeters, or you can write it down 3 centimeters, and this can be 6 centimeters. Okay. Now I've just given a measure here: 8 centimeters, 3 centimeters, and 6 centimeters. And in this triangles, if three different sides are there, means scalene triangle. It is a scalene triangle. In this triangle, so what is the first property here is given? Angle opposite to the longer side is always greater. And longer, which one is the longer side? Longest one is 8 centimeters. So if this one is the longest, means what? The opposite angles of this, opposite angles of this side is always the greatest angles in among these three angles. Okay. So opposite to this side AC is angle B. So out of angle A, B, and C, which one is the greatest angle? Angle B. Why? Because opposite to this angle is 8 centimeters. That is the longest line segment among these three sides. Correct? Among this in this triangles. Correct? So that means angle opposite to longer side is always greater. Correct? Same here, angle opposite to shorter side. Shorter, which one is the shortest one? 3 centimeters. So opposite to, which one is the opposite to this side? So opposite to this side is here. This angle is shortest, angles among this triangle, in this triangle. Out of these three angles, which one is the smallest angle? Angle A. Why? Because the opposite side is smallest among three sides. Correct? So you can just get, first one is angle opposite to longer side is always greater. Angle opposite to smaller side or the shortest side is always the least angles in a triangle. Understood? And same here, when you go towards the second one, side opposite to, side, same here, let me draw the diagram in this way. So side opposite to the greater angle is always longer. So means what? If this is 90 degree, now angle, this is 90 degree, let me give this one is 60 degree, and I'm going to give it here 30 degree. So there's got three different angles are given. That means scalene triangle. It is inequalities of a triangle. So angles are not equal at all. So among this, which one is the greatest angle? So greatest angle is 90 degree. Opposite to 90 degree is your hypotenuse. So among these three sides, in a right triangle, hypotenuse is the longest side. Why? Because opposite to this is the greatest angles among the triangles. Among this interior triangles. So now the side opposite to greater angle is always longer. So opposites. Among this 90 degree is the greatest one. Opposite to this, line segment AC is the greatest one. Same here. This is the smallest one. Angle. Side opposite to smallest. Smallest angle is always smaller, smallest line segment, correct? Smaller line segment. So you can just get in this way. Side opposite to greater angle. Side opposite to greater angle is always longer, and side opposite to smaller angle is always shorter. Do you get it? And now come to the third one. We can prove in this way. See, sum of the angles. Now see, I'll just draw a triangle like this. I'll explain in this way. The sum of any two sides is always greater than the third side. When you add it up two sides, the other when you add these two up, adding up these two is always greater than the third side. Correct? So I'll just give an example like this. If you have got if your home, this is your home, and this is your school, and this one is your temple. So if you have to reach here, your home, you can have two ways. Either you can go direct towards this, direct on this line, line segment, or you can just go like this, okay, close like this. You can just go to temple and then there's go two way, another way like this. Which one is the longer? Obviously this one. So here PR, when you add it up PR, you can just go to temple plus temple to your home RQ. PR plus RQ is obviously greater than this one is the shortest. You can just go direct to your home. So PQ. Understood? So here when you add these two up, any two up, sum of the two sides of a triangle is always greater than the third side. So this is just three properties of inequalities in a triangle. Do you get it? And now I'm just going to show only one question based on this properties, and then rest of the question this exercise and everything can do by yourself by looking at what I did in the earlier, and by looking at your properties you can come to know how to solve this. Okay, so let me solve this fast. So this is the questions based on this properties. So in figures, now in figure is already given AB and AC of a triangle. Triangle ABC are extended to point P, and extended to point Q. Okay, so respectively, and what else is given? So here it is given PBC. Where is PBC? PBC, this one. This angle is less than QCB. This angle is less than QCB. So means what? I'm just giving an example. So in case, if I'm just going to give it here, if this is 120, when I give this one, if this is 120 and PBC is less than QCB means what? You have to write little smaller way measures, okay? So if this one is 100, okay, yes, 110, I'll write it 110. So 110 degree is lesser than 120. So I'll just give an example. It's not proper. I've just given an example in this way so that you can get clear, okay? So this is not given, okay? Now see, let me prove. How do we prove? First of all, when you prove, you have to write given. Always write given first. What else is given? Okay, see here. Yes, this is your given. See here. Angle PBC. PBC is less than angle QCB. This is given. Okay. And after that you need to prove. What do you need to prove? To prove, you have to prove that this one AC. Where is your AC? AC. This one. This side is AC is greater than AB. Where is AB? AB. So you have to prove that this side is greater than this one. So how do we prove? By using this properties. Okay. So let me check here. So these two are given. Now do we need any constructions here? You don't need any construction at all. So start proving fast. See here, prove. So to prove this one, let's check here. So yes, if this is just in case, let PBC is 110, QCB is 120. Why we are giving let? Because we have got a clue here and given. PBC is less than QCB, that we have known it, okay? So by looking at the angle itself, it is more than 90 degrees, so you can just put any value more than 90 degrees, okay? So now you can just, do you remember linear pair? Wherever you are finding a straight line, when you add it up, any angles on a straight line is always getting linear pair, that means 180 degrees. So look at this line, PAP, okay? On this, when you add these two up, this angle and this angle, how much you are getting? 180 degrees. So you can write it down. Okay, you don't need to write, you can just write. We know that. Okay, when you present this answer, you can write in this way. Angle which one? ABC. Angle ABC plus angle PBC. PBC is equals to 180 degree. Why? Because you learned it in the earlier sessions, that is linear pair. Do you remember linear pair? So write it down, linear pair. Okay, so take it first. Equations, and now come to the second one. Same here. On other side, again, when you add this and this, because AQ is a straight line, so if you're adding up two angles on this straight line, it is exact getting 180 degrees. So let me add this one again. ACB plus angle QCB is also equals to 180 degrees. Same reason you can write it. Linear pair. Linear pair, second one. Okay. So now see here, this is exactly 180 degree, 180 degree. If your right hand side is equal to each other means what? Your left hand side is also equal to each other. So take here from, you can write it down, from 1 and 2 we get, from 1 and 2 we get, this is also equal to this one. So let me write it down here. Angle ABC plus angle PBC is also equal to angle ACB plus angle QCB. So you can write in this way. If these two are exactly equal, means what? This is also equal to this one. So write it down like this. Okay. Now what else you know? You have got a clue. The given is here. Okay. So this one take it as third. And now what else is given? You can write it down. So here this is given PB. Okay. PBC is less than angle QCB. Take it 4. So we have known this one. So I've just given here. Let PBC be 110 and QCB be 120. So by looking at this one, this linear pair properties, what do you know? Okay, see, if this is 110, how much will be this? And this will be 110 plus, okay, yes, 70, it is exact getting this one, yes, it is exact getting 180. So 120 is here, this will be 60 degrees. Do you get it clear? So now this is an approximate, I'm just taking, it's not an exact value, okay? So now see, we have got a clue like this, and from 3 and 4, okay, now see here, yes. And which one is greater? Which one is greater angle? Obviously this. 60 and 70, which one is greater? ABC is greater than AC, okay. So from, you can write it down, from 3rd and 4th we get. By looking at this two, you come to know that ABC is greater than ACB, okay? And once you know that this side, this angle is greater than this means what? So you have to know this one here. If your angle is greater means what? The opposite side is always greater than the other side, got it? So now see, and here 70 is greater than 60 means opposite side of this angle is AC and opposite side of this angle is AB. So if you know that ABC is greater means what? AC is obviously greater than AB. So AC is thus. So you can write it down thus. AC. Okay, AC is greater than AB. So we prove. Okay, AB. To get it, hence we prove. You can write it down, hence we prove. We prove like this. Okay, so by looking and making in this way, you can get more clear. So see here, your question is to prove AC is greater than AB. So first of all, to get this one, you need to prove that this has to be greater means what? This has to be greater. Opposite to this is this one. So once you prove that angle is greater means opposite side is always greater than other side. Got it? So we prove that AC is greater than AB. So you can prove in this way. Got it? So the properties are very important. You have to know how to prove the theorem, and by using those properties, you just come to know how to solve all the exercise, and our problem will be easy for you. Okay? And if you're still finding difficult, you can just write to me through Tibettv. Okay? So thank you for now, and see you in the next session.